Hi there. Today we're going to talk about statistics and data exploration. These two topics are closely interrelated in a way that statistics allow us to see a general picture and also dependencies inside our label data, while data exploration helps us to explain why we have these dependencies. So it's important for us to quickly navigate to the underlying images and to see why certain statistical artifacts take place. Uh, it might sound a bit abstract at this moment, but don't worry, I will explain all of that in this video. So let's start. We have here a Pascal Voc. Let's open that project. So this is a common data set, and let's take a look at classes first. So we see about 20 classes, each of which is associated with bitmap shape, and those are common classes like person. Let's take a look at statistics. So the first thing to notice is that among our three data sets, the largest one is train well. Let's explore image statistics. So this one relates classes and number of images in a way that for each data set, say, well, we know that there are 446 images that contain persons. And we have these amounts for all the data sets inside the project. And overall, there are 1,776 images with persons overall. So, and this kind of statistics we have for all the classes. We also see that all the images are labeled in our project. So, we have 0 images without labels for every data set and overall. In Pascal Voc, there are no tags associated with images, and also there are no tags that are associated with any objects. So the next page allows us to investigate object-related statistics. So again, it tells us that in train dataset we have 870 persons, instances of persons. So it's not like the number of images that contains persons, it's about number of instances. And that number we have for all the data set and overall. And again, the same numbers we have for all the classes in our data set. So that, for example, here we can see the total number of object instances overall, and it's about 20,000 objects. We have one section left, objects area. Let's investigate that. So here we see for each class how much area is occupied by this class. And this is pretty interesting because, say, first we can sort and see that the most area is occupied by neutral class. The second object that occupies the most area is person, cat, and so on. This statistics is important for the following reason. So we might be interested to have some kind of balance, so that if we have a person in training set, we have approximate number of area occupied in another data sets, so that our statistics is consistent across data set. And for Pascal Voc, just a quick look at the numbers allow us to make a conclusion that yes, we have this consistency. So far, we have investigated basic statistics available in Supervisely, but it's still limited in a way that these are just numbers that we see. What ideally we would like to get is the connection of these numbers to actual data. And let's see if we can achieve that. So let's open train dataset. Now we're inside image labeling interface, and we have quite a number of images here. And ideally, there is a way for us to get some insights regarding these images and the labels. So what we can do, we can click on filter button here and add some filters. So for example, we can try to find objects of particular classes, say motorbike. Let's apply the filter. And we will see that there are 81 images that contains motorbike, and we can navigate to inspect them. Maybe we want to identify images that contains like a lot of motorbikes. So let's try this. So like four motorbikes or more. So we see that there are only 2 images that satisfies this condition. Let's pick another class and do the same exercise. So let's see. Maybe the class will be say ship, and maybe we'll put just one here. So, and we can see that in our data set there are 63 images that satisfies the condition. So let's see what other options are available for data exploration. So there are some predefined filters here, and also we can filter by file name. Sometimes labeled images contain tags. Sometimes tags are associated with objects, and sometimes we might be interested in identifying objects or tags that were labeled by a particular annotator. Sometimes images might contain issues, so that we can use this instrument to navigate. Though these filtering options might be quite useful for data exploration, there is still one drawback. And this drawback is that these data exploration techniques are not related to statistics. So first we take a look at statistics, and numbers were not enough for us. Now we don't have these numbers, so we just have kind of convenient way to navigate via data. But what if we could do both? And in the next section of this video I will show that. So I am back to the dashboard, and here is the Pascal Voc project. And my task here is to showcase how we can put together statistics and data exploration. So the way I will do that is by relying on applications, and I will use 2 of them. One is class stats for images, and the other is object size stats. So let's start with the first one. So application asks me about sample size, and in some cases I might want just to take a small sample and calculate statistics. And in this case I will just take 100% of images for Pascal Voc. So let's run it. The application is started. It might take some time for the application to calculate all the relevant statistics. So let's open it. We don't have to wait until the process is completed. Okay, it will probably take a couple of minutes to finish, so I will be back when the calculations are completed. Now we have the statistics ready, and the report is available by this link in file section, so you might find the report that you have generated in the file section. And this report contains several tables like those one, and also several charts. But I will be mostly interested in the first table. This table is quite large because it contains, so each row of this table includes the link to the image. So the number of rows equals to the number of images. And let's see what we can do here. So we can use a column, say any column, but let's pick, say, height. Click on that so that the images are sorted in a way that the images with the smallest height on top. And we can click on image. To see this, that yes, the height is quite small, and that is a potential outlier. Let's sort in opposite order, and we will immediately notice that the highest height for all images is 500 pixels. We can do the same for width, but let's switch to something more interesting. So there is unlabeled column. If we click on that, we will see here the images that are fully labeled. So means that unlabeled equals 0 means that the images are fully labeled. Here is an example. Let's sort in opposite order, and we will find that these top images are mostly unlabeled. So like 99.7% of pixels are unlabeled. Let's see what this image looks like. You see only a small portion is labeled, so this tiny car here. Let's take a look at another example. Here we can also see a quite sparsely labeled image, so that is a potential outlier. Let's inspect this table further. So you might see that there are columns here that correspond to the class names. So for example, we might pick a column and click on that so that the image here contains the maximum number of objects of specific class. So this image should contain like 19 ships. Let's see. Yeah, indeed, quite a lot of ships in this image. So overall 20 objects, but one object is neutral, so it looks like it got it right. Another column called ship means that I can also click on that, and it shows me the image for which 75% of pixels are labeled as a ship class. So again, let's click on that. Yeah, we can see that the statement is correct. So we see only ships on this image. Let's keep doing this exercise for a couple of more classes, say bus. Let's click. Maximum 7 buses. So let's see. So we can see that at least 7 objects of class bus is here. But it looks like it looks close to the truth here. So let's keep going. What about cats? For cats maximum, and maybe I am interested in the last one. Let's calculate the statistics for a person. Not calculate, but rather try to find. So I can deselect all, and maybe include several objects of interest, several columns of interest. Yeah, persons here. Let's see. 15 people maximum. Okay. Yeah, it looks like true. There are quite a lot of people on the background. And it seems that the number might be actually larger. So I think that you get the point what I'm doing here. So I'm trying to look at different statistical properties and immediately get an access to the images so that I am sure that statistics is correct. There are some other elements, some other components in this report. I will not go further here. And instead, I will show you another report. Let me show you another application that connects statistics and data exploration. So this application called object size stats, and this application essentially generates a report. So let's run that. I will take sample size equal 10, so that I don't have to wait. So the application is started, and we can open that. Here is how a report looks like. Number of charts and several tables. But I'm mostly interested in the first table. So each row in this table is essentially an object. So the total number of rows in this table equals to the total number of objects in our project. So let's try to find an object that has the smallest height in pixels. So let's use this column to sort. So what we see is that there is an image that contains class boat, object of class boat, and this boat has 1 pixel height. So that's really strange. Let's take a look at that. It seems that statistics is essentially correct because there are 3 boats here, and take a look at this one. So here it's the height is equal to 1 pixel. So let's go back. There are objects that for which height is equal 3. So for example, this car. Let's take a look. So let's see. Yeah, it seems that the car is the car we are looking for is far away. So can zoom in. Maybe this one. Hard to say. Okay, let's close it. We can do the same, say, with width. Yes, there are person who has the width of 1. So maybe we are more interested in some particular class. So say what it might be, say cat. And this operation allows us to do the same. So the cats are relatively high. So the cat with minimal height is the minimal height for cat is 73 pixels. What about width? Yeah, the same. And we can do this operation on a class-by-class basis to get a better understanding of what kind of data we have. Again, there are a number of other tables in this report, but I will not focus on that much. In the last section of this video, I will talk briefly about the reports and potential other tools for data exploration. In the last section of this video, I will tell a few words about the reports that we have investigated earlier, and also about another potential tools for data exploration and statistics. So the reports that we have seen were generated by these 2 applications. And if we go to ecosystem apps, we will see another applications that are currently available in Supervisely. There are not a lot of them, 25, but we hope to get much larger amount in the long run. So we hope we will have like hundreds and hopefully thousands of apps. And if we click on data exploration section, we will see the applications that were responsible for the reports that we have investigated. So let's just click on one of them. This was the first one. Here we see a documentation and how to run the application. So you have to add app if it's not already added. But the most important point here is that these applications are open sourced and you can go to GitHub to see the implementation. So I will just briefly go through the implementation. So config file, JSON config, specify among other things where to find the application. So it tells that you might open a context menu and this application will be available for images projects and for images datasets. And the application will be available from report section. If the report section is not exist, the application, when you add it, will add this item in the menu. So let's briefly take a look at source codes. So this is 12 lines of code for the first model windows that we have seen. So we put 100% here. This is sample size. This file represents graphic user interface, and it's 74 lines of code, but recall there were quite a lot of widgets, charts, tables, and the main reason for that is that we have so-called supervisely table. Let me find it somewhere here. Yes, this widget. So we don't have to implement a lot of logic. And then the last source file have left, and that is Python file. And Python file is responsible to populate these widgets with data. And overall, it's about 350 lines of code. So you see that there are essentially 3 files and quite a lot of technical features. And it will not be very hard for us to add more of those. And it will not be very hard for you to implement your own applications that fit your requirements. So I think that's pretty much it. And thank you for watching. See you. Bye-bye.